Okay, Darren, what? Okay, so let's get started. A bit messy. Okay, so today, can you all hear me? Can some human speak?
Yo, can hear you.
Yes, good. Okay, so today we'll talk about correlation and regression. Now, importantly, correlation, relation.
Hello.
Yes. You what?
Go share screen.
Oh yeah, never share screen, huh? What am I trying to do, huh? Correlate. Share screen. Okay, my screen should be shared. Can see or not?
Yeah.
Okay, so correlation is basically to correlation is actually to know how well two variables, so let's say your x and your y variable, use the word in vaguely, moves together. Okay. So for example, if x increases, y also increases, then this we say that it is a positive correlation. Okay. Now, if it's the opposite direction, if x increases and y decreases, or x decreases and y increases, then we say that it is a negative correlation. Okay. Then what we have is, if it is a positive correlation, it also means that the gradient in this case, the gradient is m. We can also use this symbol as b. We can use this symbol as beta. Beta 1 is positive. Okay, so if it's a negative correlation, then everything is negative. Okay, so generally when we say correlation, we are actually referring to Pearson's correlation. Okay. Now, in order for Pearson's correlation to be used, there are two major criteria. One is the data, the x and the y, must be normally distributed. Okay. The second is the data is ratio or interval. Okay, that means if it's ordinal, it cannot use. And Pearson's correlation is used by this symbol small r. Is there a limit? That means upper and lower boundary of large R and small, upper and limit boundary of R.
1.
What one? Between what and what number?
Oh, 0.91.
No.
Don't understand.
That means what is the lowest value for correlation, or what is the highest value for correlation that you can ever get?
You say 1, -1 to 1.
Minus 1 to 1, inclusive. Okay. So that is the basics of it. So let me continue. Okay. Then the next part is, this is the equation for Pearson's correlation. So it's R. Okay. Pearson's correlation is given by a formula. Your x value minus of the mean of x, and y minus of the mean of y. And you have the x1, 2, 2, 2, 2, 2, y. Okay. So that is the Pearson's correlation in the first place. Okay. So let me see, what do I have? How do I go to the next screen from here? Okay, let me see, where do I stop here? Okay, so given that, okay, yeah, okay. Now, you also in Excel, let's say Excel, you actually see this term called R square, or sometimes we also can write it as R square. This is essentially Pearson's correlation times Pearson's correlation. All right, but this R square is actually have another name for it. It's called coefficient of determination. So what does coefficient of determination means? Let me just give you an example. Okay, you have done experiment, you have done protein quantification. So if you want to do a protein quantification, let's say you want to find what is the concentration of, let's say, unknown protein, for example, BSA. Okay, so first step, you actually do a standard curve. So standard curve, you can actually use your albumin. You take your albumin, you go through, you dilute your albumin, zero dilution, and then you do your burette assay. Okay. So what you end up with is a table that looks like this. Your albumin concentration, and your OD280. So you have multiple readings. So for example, here you have 10, let's say, milligrams per liter or so on. Okay, let's say 100 milligrams. So you have 90, 80, 70, and all the way to 0. After that, you take these results and plot into a graph. Okay. So you plot into a graph, you have your OD280 reading and the concentration of your albumin. Okay. You start from 0, so you have here, and so on. Okay. Then by your lead, you draw a best fit line. So the best fit line is this thing called, this is your best fit line. Okay. And your best fit line actually have an equation that is OD280 equals to the gradient of your albumin plus your y-intercept. The y-intercept can be 0. And based on this, assuming that you get R equals to 0.9, it means that what is the R square value? If R is 0.9, what is R square? Somebody?
0.81.
0.81, correct. So 0.81, what does this value really means? Okay. If you put it, it means that 81% of the variation of the y-axis, let's say OD280, is explained by the x-axis, concentration of albumin. Okay, so remember your experiments, you may do triplicates. Let's say in this point, you have 10. If you do triplicates, are all the OD280 going to be exactly the same? Let's say you do triplicate experiments, are they going to be the same?
No.
Okay, not likely. It may be similar, so you have a point that looks something like this. So what are all these variations? That means there are some variation in your OD280 that is not explained by the albumin concentration. So this also means that you have 19% of the variation of the y-axis, OD280, is not explained by your y-axis. And quite importantly, this 19% will include all the errors. It will include things like your dilution error. It can include things like your pipetting error. Even your machine calibration, even the sensor fatigue. This is why we always do, when you do all these experiments, we always tell you that don't leave your spectrophotometer cover on because the sensor can be stressed out. Okay, so that is what your coefficient of determination really means. And it can be very useful. The better it is, Pearson's correlation coefficient, the closer to 1, the better it is, or closer to -1, the better it is. Okay. Now, so we come to a next step. Once we can find the correlation, okay, so we say that if there is a logical correlation, okay, anything can be correlated. I'll talk about it later. So this correlation must be logical, means it must actually make sense. Oops. Then we want to find out the equation linking y and x.
Sorry, what is the highlighted word?
Logical. That means the correlation actually makes sense, because later I'll show you that a lot of correlation doesn't make sense. Okay. So what we are trying to find out is your y equals to, if it's in straight line, assuming a straight line, y equals mx plus c. Okay. So y equals mx plus c, during the lab, I told you that statistically we tend to write it as y equals to beta 1x plus beta 0. On your calculator, it will be written as y equals to bx plus a. So these are the same meaning. Now, let's say you do your experiment and you have your y and x. Okay, hold on. Okay. So how do you draw your best fit line based on what you have learned in secondary school? What are the rules that you use? Anyone still remember? What are the rules? How do you draw a best fit line? What are the method that has been taught? Dexter? Anyone? Quick. Hello?
The graph is distance between each data point is not very, like, it's minimal.
So usually the secondary school teacher will tell you two rules. One is the number of points above the line should be equals to the number of points below the line. Okay, what is the second rule? Is it just the number of points? There's actually one more thing. So Ken, what is the second rule?
The distance between the point and the graph. I don't know.
So the distance between the points above and below should be equal. Okay, so essentially that is what we are trying to do here. So what does this really means is, let us just look into this context. Put this into the graph. What does it really mean? Let me redraw the graph. Okay. Okay, so let's say at 5. My best fit line will mean that the error, that means this gap, okay, that is actually here. The gap, so I call this gap E, the distance E, and E. Okay. If the distance between above and below should be equal, it really means that the summation of all the positive errors plus the summation of all the negative errors should be equals to 0. Make sense? In other words, remember in statistics, because it's positive and negative, we tend to square them. So this also implies that if I square all the errors, I'm trying to find out what is the gradient and y-intercept, the intercept in the so that the summation of E square is the smallest, or the okay. And because we use square, that's why the method is called the least square method. Okay, smallest, it is least. The square is the square. This is called the least square method. All right. So let's just look at a linear correlation to be linear regression to begin with. It also means in this case, the purpose of regression is to get the equation. Okay. So how do we actually physically do that? Now, assuming that you have a list of x and y values, you want to put all this into y equals bx plus a. Okay. So the equation for finding b will be then this. Okay. So once you do that, then what you do is after you find b, you substitute b into this equation. Average of y equals to b times average of x plus a. So a equals to average of y minus b to n multiplied by average of x. So this is how your calculator get the a and b for you. Okay. This method is called the least square method. All right. So far, any problem? You don't have to know the equation because all is in your calculator already. Just have to learn how to use the calculator. Okay. Okay, so the last thing that I want to say is actually very important. Is this thing. Anything can be correlated. Okay, let me just use this first. Anything can be correlated. Okay, and because of that, correlation does not equals to causation. Correlation does not equals to causation. This is the mistake that a lot of false news, fake news will tend to use. Say correlation is causation. Okay. So let me just give you a simple example. And this is a real life example. Let's say this is months. We have January, February, March, April, May, June, July, August, September, October, November, and December. Okay, and this is the frequency. We have two frequency axes, doesn't matter. So one line will go something like this. The other line may go something like this. Do you think that these two lines are correlated? The data points, do you think if you plot it out, they are correlated? One increase, the other increase, one decrease, the other increase. Do you think they are correlated? Someone?
Yeah.
Yep. So they are correlated. In fact, they are very highly correlated. But if I tell you that the red line and the black line means something interesting. The black line is, let's say, I'm plotting ice cream sales. The red line, I'm plotting number of shark attacks. And this is a real data. Does it mean that ice cream sales? So I'm asking you this question. Does it mean that ice cream sales causes shark attacks? Yes or no? Does it mean ice cream sales causes shark attacks? No. Why? So no. Okay. Ice cream sales doesn't cause shark attacks, you know it. Unless you're trying to say that the more ice cream you eat, you taste fatter and sweeter for the shark to attack you. So why do you think these are correlated? These two are correlated.
Maybe because of the season.
Yeah, so you look at here, May to about September, this is a summer season. Okay, and in Northern Hemisphere, summer season is where people buy more ice cream because it's hot, it's warm, and they go to the beach. So these two, the underlying principle, the underlying idea is summer. You are going to places whereby more shark attack happens. So please take note of this. Okay. Anybody know who is Nicolas Cage?
Yes.
Nicolas. Okay, so let me show you a website which gives very interesting correlation data. Okay. So, okay, this website. imported code rate. Okay, not my problem. Okay. So here you have, and it's from the source is from US Office and Budget and CDC. Okay. So US spending on science, space, and technology is very well correlated with suicide by hanging, strangulation, and suffocation. Look at the R value, 0.99. Very well correlated. Okay, but it doesn't mean anything. Okay. And the next one, Nicolas Cage. For those who do not know, this guy is Nicolas Cage. And Mr.
Ghost
Nicolas Cage.
Rider.
Huh? What?
He's the Ghost Rider.
Is it? I don't know. Yeah, correct. He's a Ghost Rider. Yes. So, okay, it's still a good correlation, 0.6, 0.67. The people who drown by falling into a pool correlates with the number of films Nicolas Cage appears in. So Nicolas Cage should not act at all, if that's the case. Okay. And here, the number per capita cheese consumption means how much, on average, how much cheese a person eats is very well correlated, about 0.95, with the number of people who die by entangled in their bed sheets. Yes, people do die by suffocating themselves in bed sheets. Okay, and it's actually quite high. See, per year you have about 800 deaths. Okay, divorce rates in Maine, which is a state northwest of America, is very well correlated, 0.99, with margarine consumption. Okay, Miss America with murder by steam and hot vapors. What else? Okay, people who drown from falling off a fishing boat correlates with marriage rate. And this is quite another one. Yeah. The number of winning letters in National Spelling Bee competition is very well correlated with the number of people who died by venomous spiders. Okay. So that's why correlation is not causation. All right.
Sure.
What?
Then how is like in this kind of case, right? Then how is correlation even useful? Like let's say like the thing is like not even connected in the least bit. It's just like the data is just similar only. Then
Correct.
Like 没有用 right?
So correlation doesn't equal to causation. You can only say that. Okay, let me just wait. So how is causation? Causation can only be shown in experiment. Causation can only be shown in experiment, which means that when something is correlated, you try to see whether is there a reason for correlation. Is there an underlying reason for correlation? Like for example, this ice cream sales versus shark attack. It tells you that there's something there happening. It may be something happening, but you have to go and dig deeper. It doesn't mean that one is causing the other. There may be a lot of underlying reasons behind it. So there is still some use. Correlation, there is still some use. It just doesn't mean causation. It just asks you to say that there is something underlying there that may be quite useful for you to find out. Got it, Ken?
I think it's Dong Tai.
Dong Tai. Got it? What is You're trying to shit or what?
No, like wait, what you want me to say is
No, who is the one that asked me just now?
ask you the correlation thing
Yeah.
Me lah.
Yeah lah. So do you understand what I'm trying to
Yeah.
say?
Yeah lah, understand lah.
Good lah then.
Oh, okay, take
Okay,
it,
so
take it.
with that, so with that, let's go to our tutorial question. Okay, tutorial question, let's say go to question 1. Okay, question 1. If you run a least square line regression, suppose that you add another observation and run a new least square regression, the line will definitely be different, true or false. So, oops. Where are you? Okay, let's go in alphabetical order. Okay, no more alphabetical order. This doesn't show up. Okay, let's try this. Sherwin? Question 1A, true or false? Hello? Amina? Amina?
Give me a minute. 1A. I don't know the answer, sorry.
Okay, hold on. My laptop is giving me problem again. 1A, the answer is false. It doesn't mean that when you add, okay, hold on. This is not functioning. Why do all this stupid thing pop up? Okay, 1A is false because the newly added data point can be on the regression line. If it's on the regression line, then it doesn't make a difference. Okay, 1B. If Pearson correlation equals to 1, Spearman correlation must be equals to 1. Is it true? Clara?
True.
Okay. Spearman correlation is always higher than Pearson's correlation. Okay. 1C. If the sign of Pearson's correlation is negative, the slope of linear regression will also be negative. I mentioned that just now. So, Daniela? Daniela. Yeah.
I think it's true.
True, correct. It is true. Okay. 1D. Homoelasticity is a term for linearity of random errors for all value of x. Danielle?
False.
False. Okay. Homoelasticity is equal variance. Heteroelasticity is unequal variance. So t-test assuming equal variance in some books will be written as t-test assuming homoelasticity. Okay. 1E. Linear regression is always appropriate when you have two variables measured on ratio scale. Who is next? Darren? Darion. Darion, where are you? Okay, next. Alicia? Ezra?
I'm not sure.
You're not sure. Okay. It is false. Okay, for a few reasons. One is regression should only be used when you think that there's a causation effect. Okay, by writing the regression, that means the equation, you actually put something equals something, so there's a causation. Remember, it's not always possible. Okay, so question 2. Which of the following scatter plots will have correlation coefficient of -1? And anyway, the full name for Pearson's correlation is called Pearson's product moment correlation coefficient. Okay, so which one? Tong Tai. A, B, C, or D?
Well, I mean to be honest, 我不会做啦 bro.
Make a guess lah.
Guess
Negative one.
uh B.
Yes, correct. B lah. Yeah, it's true. B. Because one goes up, the other comes down. And it's
Nice.
perfectly on the line. Okay. All right. So the three, question 3 is actually a little bit tricky. Most of the time, I'll say that most of the time we use Pearson's correlation wrongly. Simply because Excel has it. Most of the time we should use Spearman correlation. So Pearson's correlation, remember, should only be used when both data are both interval or ordinal, and they must be normally distributed. So if whenever one of them is not ordinal or is not interval or ratio, you should not use it. So I just give you the answer. It will be Spearman, 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 and the rest you can use both. Whenever you can use Pearson's correlation, you can always use Spearman correlation. Okay, whenever you can use Pearson's correlation, you can use Spearman correlation. Doesn't matter. All right. Question 4. Which of the following lines do not represent a monotonic function? Monotonic. Noel? Noel? Are you there? What happened, huh? Rasid? Okay, back to Darren. Darren, are you there? Darren, question 4, what's your answer?
D.
B, correct. Okay, question 5. Since you're there, must well just answer a few more questions. Question 5, where are you? Okay. So a teacher wants to investigate the running speed of children related to their age, and you have a number of students who run 200 meters. Okay, so part A tells you that you use a model y equals to mx plus c. So what is the R value that you get? Darren?
Negative 0.912.
Right, negative 0.912. B. Do you want to answer the entire question or not?
No.
Why? Okay, don't answer then. Noel, are you there?
Yeah,
Yes.
sure. Can I ask
What?
for the question 1B, right? Why is it R equals to 1, then RS equals to 1 also?
Okay, Spearman correlation is always giving a better result. Okay. In fact, when Pearson's correlation is equals to 1, when you rank them, it's always proportional. That's the reason. Okay, because remember we do a ranking for Spearman. So when Pearson's correlation is perfectly on the straight line, when you do the rank, it will still be proportional, will be still on the straight line.
So whatever number is reflected on R, it will reflect on RS as well.
Not necessary. It's only one. When Pearson's correlation equals to 1, Spearman will always be 1.
How about when R is negative 1?
You will also be negative 1.
Okay.
Only these two opposite cases. Okay. Since you are there, answer question, where am I? 5B. Okay, where's my 5? 5B, 5B, 5B. Okay, so you are asked to put a model y equals to m times reciprocal of x plus c. So what is your R value?
0.992.
992. Okay, stay on for the next two parts. So part C, which model is better?
Okay, which model is better? Second one,
Second, okay. So second model is better, but why?
because you have a closer R value to 1. Closest to 1.
Okay, because what you should write is the absolute R value is closer to 1.
Yeah.
Okay, so part D is, does a scatter plot support your answer to C?
Wait, can I say that how shall I, because it is positive?
No, because
Eh?
negative also.
Oh yeah, shit, what am I talking about? Yeah, okay.
So
Yeah,
D.
yeah.
What is your answer for D? D, 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 D. 3, 4. Okay, answer for D is yes, there is a scatter plot shows a linear relationship is stronger in the second model. Okay. Okay, so question 6.
Wait, before that, right? For 1B, what if it's not 1?
If it's not 1, then it's hard to say.
Or,
It's difficult to say.
okay. Then for question 4, right? The rest is all monotonic, is it?
Yes, correct. Monotonic simply means that one goes up, the other will go up, or one comes down, the other will come down. For D is it invert. In certain range, A go B, in certain range, X go increases, Y increases. But in certain range, X increases, Y decreases. That's what it's called. It's not monotonic.
Okay. Thanks.
Okay, so question number 6. Okay, 6A, same thing. Okay, let's say for 6 first. Let's get this part. You have temperature as your x-axis and volume as your y-axis. Okay, so 6A, y equals to mx plus c. What is the R value? What is the correlation coefficient? Yola?
0.632.
0.632, correct. So 32 to answer the second one as well. If you have another model that is okay, so this means just change it. This is bx plus 8. Okay, so bx squared plus 8. So what is the R? What is the correlation?
0.792.
0.792. Okay, next person. How to pronounce the name? Sinjen. Which model is better? Are you there? Sherlyn, which model is better? Sherlyn.
I don't know how to do this question.
Okay, the model is better when the correlation coefficient is higher or lower. That means the absolute is closer to 1. That is a better model. So which model is better, A or B?
B.
B, yeah. Okay, model B is better. Okay, then you find what is A, what is B. That means you find the two coefficients. Okay, so the two coefficients, Minal?
Yeah. A is negative 91.2.
91.2
Yeah.
is 92.1.
Sorry, 92.1. And B is 1.78.
1.78. Okay, so by that, what you have is this model. Since model B is better, what you have is this model. Y equals to 1.78 times your x squared minus 92.1. So for question D, what okay, so if the temperature, that means if X is minus 10 degrees, Y will be the volume will be what? Yeah, me now. Do the whole question now.
Y volume. Okay.
So you substitute
89.445.
85.9. Just now I think you just calculate you write this wrongly. That's why you have
Oh,
okay. But do you think that is the answer is reliable?
yeah, I think it's reliable because it's more than 0.9.
What is more than 0.9? No, you see that this is it more than 0.9? Okay, so the answer is it is not reliable because the R, absolute R is less than 0.9. Okay, look at here. It's 0.792. Where do you see it's more than 0.9?
I see wrongly, sorry.
Okay. Okay. All right. So question E, is there an outlier? So let's have another person. Xiang Yuan, is there an outlier?
There is the last one.
The last one, right? Right. So it is the 20 and about 900. That's outlier. Okay. So if you remove that and you recalculate for model A, removed and recalculate the business correlation for model A, which is actually y equals to bx plus A. So what is the R value? Xiang Yuan, same.
I haven't punched calculator.
You have a bunch of calculator. So who has done that? Hannah? Hannah,
I don't know how to do.
you don't know how to do.
0.434.
0.4, no, not 0.432.
0.99.
Yeah, so it's
Oh,
0.99. So it's 989. Okay. So you can check
sorry,
calculation.
this one is usually model A or B.
A, look at the question.
Oh, lava.
Read the question. Don't anyhow blindly do. The question already say, by removing this outlier, recalculate the coefficient of linear model A.
Yeah. Okay lah.
Okay. All right. So last question. Question number 7. Okay. Accountant monitors the items. Okay. So you have the production. Okay. And you want to fit it into y equals to y equals to bx plus a. Your y is the production cost. Okay. Production cost is in $1,000. X is the number of items produced. It's also in the unit of 1,000. Okay. But A, is there any outlier? So, Brandon, is there any outlier? Look at the scatter plot. Is there any outlier? Brandon. Okay, Sabrina. Is there any outlier? Sabrina. Sherwin.
Don't have.
Don't have. Correct. No outlier. Yeah. Okay. So no outlier. Okay, question B asks you to find the correlation. So you put it into this equation. So what is A, what is B, and what is R? Okay, Tanisha?
A I got 20.99.
Okay, 20.99.
B
B?
I got 0.98.
Three decimal place.
Oh.
3 decimal place, yeah. So
Then 0.978.
978. How about A?
I don't know, I just copy like that.
85, okay. So R?
R I got 0.998.
Correct. Okay, so you put it, substitute into the equation, it means that y equals to b will be 0.978 x plus 20.985. All right. So C, comment on the relationship. Okay, let me just show you how to comment on relationship of two variables. Okay, there is a set of words that you need to use. Number one is whether is it strong or weak. Okay. Second set of words to use is whether is it positive or negative. Third is linear or non-linear. So what are the differences? Strong is when the absolute R value is more than or equal to 0.9. Positive when your B is more than 0. That means positive gradient. Linear when it is a straight line. So this is the simple rule.
Wait, so means we don't need to like use the one in the notes like very weak, then like weak, moderate, strong, very strong. Like just need either strong or weak.
Yes.
Okay.
So yeah, since you're there, how you describe it?
There's a strong positive linear relationship between the production cost and number of items produced.
Correct. Strong, positive, linear relationship. Okay, between the production cost and number of items. Correct. Number of items produced. Okay, so let's look at D.
Wait, but then right, what if the relationship is like monotonic?
Monotonic then is not. What do you mean?
I don't know. Like when it's non-linear, then if it's monotonic.
Okay, so then it's still non-linear.
Oh, okay. So monotonic is under non-linear. You don't just say monotonic.
So linear, it must be on a straight line. That's why.
Yeah.
So
Okay.
question.
Then
Okay.
can you use spearman for like linearly related?
Yes, you can. You can.
Oh, okay. Not just the monotonic one.
Just that when we tend to use Pearson's, because Pearson's, you have it in your calculator, you have it in Excel. Spearman, you don't have it in your calculator as well.
Oh, okay. Then for monotonic, can you use Pearson?
Yeah.
Oh, okay. Thanks.
So, so what you are trying to find out is what is the production cost for 70,000 items. Okay, so who has the answer? Wei Fang?
Is it 89.445K?
Alright, yes. So production cost is $89,445. Okay, and is it reliable?
Yeah, because the R is more than 0.9.
Okay, there's two. Reliable because R, absolute R is more than 0.9. And the second one is it is a interpolation. Okay, it's not extrapolation. Okay. E. What? Let's say the production, the sales price of each item is $2.20. Find out what is the minimum number of items we produce so that the company doesn't suffer a loss. Okay, let's go back to whoever wants to answer. Amina?
E, right? So
Yeah.
2.20x is like more than or equals to 20.985. Wait, just want the final answer, is it?
Yeah, just find answer first.
Oh, okay. So x, the minimum is around 17173.
Correct. So minimum number of items is 17173. Okay, because you have 2.2 x has to be more than or equals to 20.985 plus 0.978x. So when you calculate that, x is more than or equals to 17.1726 thousand items. Okay, therefore it is more than 17173 items. Okay, good. That's all for today. Any questions?
Yes.
Wow.
What is meant when it says to conclude with the R2 value? Like for the lab assignment, they ask to conclude with R2 value. Like what do they mean by that?
R square value.
Yeah.
So what do you think it means?
Is it like what you said just now when like the 81% of the variation of y is explained by x? Is it something like that?
Yeah.
So you just say like those two statements and then that one is what is meant.
And yeah, is it reliable? Is it what is the relationship? So you have to state your own views.
But like what are the points for that?
Just state whether what is the relationship and what does it really mean? What does R square really means? Basically, you stated already. You've given all the answers.
Just the two lines.
Yeah.
Oh, but then like which? So you just say the two lines and that's sufficient to conclude.
Yeah.
But then you say include your own opinion.
So what is your own opinion? Is it useful? Is it not useful? Whatever.
But then
Okay, you got lost. Yeah.
what's an example of like a useful one?
I make you. What
What?
did you say? Your last 2 minutes.
I don't know. I got removed.
Okay. No, just write what you can. The main thing is make sure you write sense. I'm okay with short answers. Short and nice answers. Don't give me long and boring answers.
Okay.
Yeah.
Then
Yeah.
right, like for the question 3, it's not really like clear which one is the independent variable.
No, because correlation, there's no independent or dependent variables.
So then it doesn't matter which one is in the X, which one is in the Y.
In correlation, it doesn't matter.
Oh, so either way can lah.
Yeah. I showed
Oh.
that to you in the lab already. It doesn't matter which one.
Okay.
Oh, no wonder the R value the same.
Okay, thanks.
Because if you look at the equation, right? See, if you look at the equation, this. Does it matter which one comes first? Which one is X, which one is Y? It's A times B equals B times A.
OCE lah, OCE.
Yeah, lor. Actually, there's one thing I never go through. By now, you should kind of realize a few things is this. Look at the equation for your regression, for correlation, and then look at the for your what's this? Okay, anyway, don't know why this keeps coming up. Okay, so what I'm trying to ask you is this. Okay, there's actually a relationship between your correlation and regression. So if you want to find out, I actually have the maths behind it. So I will put it in the slide so you can go and read it for yourself. Okay. That's not necessary, but if you want to find out, that's what it is. Okay, any other questions?
Is it the least square?
Correct, yeah.
But we don't need to know the equation, right?
We need to know the maths behind it. Yeah, but because the numerator and denominator keep coming up, so it's useful to get some idea lah, if you want to understand it better. All right. Okay, then that's all for today. Bye-bye. Hello, bye-bye.
Bye.
Bye-bye.
Thank you.